Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. So welcome to our 13th session of webinar series, Leaders of Enterprise, brought to you by the Faculty of Engineering, University Technology Malaysia, Johor Bahru. So we are initiating university-industry collaboration as a platform. We call it the Leaders of Enterprise to share their thoughts from the company, way forward, and challenges, especially during this COVID pandemic. So now we are streaming live from the Facebook Faculty of Engineering, University of Malaysia. So today we have a special guest. So I would like to invite Mr. David Leow, Sales Director, Advanced Retail Solutions in Berhad. Please welcome Mr. David.
Hi, very good morning, Prof. and the
Morning,
audiences.
David.
Yes, thank you for the invitation for me to share with UTM and also with fellow audiences on how can the enterprise go digitalized in
Yes.
this post-COVID, not to say post-COVID-19, during this pandemic period.
Yeah, we're still in the pandemic,
Yeah.
David. Yeah.
Yes, we still have a
Yeah.
lot to do. Yes,
Sure.
that's correct. Yeah.
Thank you very much, David, for
Yes, thank you, Prof.
accepting our invitation, and it's our privilege to have you with us today, actually. So, yeah,
Mhm.
to the viewers, Mr. David today will share with us the webinar titles Industry-Acedemia Collaboration Towards Industry 4.0. Yeah, David, that's your
Yep,
today webinar series. Yeah.
that's correct.
David, maybe
Yeah.
our viewer would like to get to know you well about yourself, your background. Probably you can share with us a little bit about your background. Yeah, until to this situation, you're a sales director now, right? Yeah, yeah. Please,
Okay,
yeah,
yeah,
share
yeah.
with us. Yeah.
Yes, so I'm actually, I will start with my tertiary education. I'm actually a product of GMI, German Malaysian
Mm.
Institutes. That was like 13, 14 years back when they have only two courses on that point of time, which is the under production technology for tool and die and plastic mold. So I was the student
Mm.
under tool and die. I made 3 years diploma in GMI. Right after the completion of my studies in GMI, I
Mm-hmm.
went to a company as a tool designer for 1 year. So
Tool
I
designer.
actually handle designs, CAD/CAM, tool set testing.
Hello. I think we have a problem with connection with Mr. David. Yeah. Suddenly his internet connection disconnected. Yeah. So I believe that we have to wait for our IT staff looking after the problem and issues. Yeah. So we have to yeah. Uh, so while waiting for that, actually, I can share with you a little bit. Actually, what Dr. Mr. David Leow, he's the sales director, the Advanced Retro Solution Nusantara Berhad. Yeah, I get to know him because he came over to UTM some time ago, actually before the COVID pandemic. Yeah. Actually, he would like to share with me about the industrial revolution 4.0, which we know, known as the IR 4.0, because he is very experienced in the, especially in the production manufacturing, tool and die, and he graduated from the one of the institution in Malaysia. So yeah, then during that time he working with another company. I think now he went with this. He come with this company. So then I would like to share with us as all the viewers today his experience on the IR 4.0. Yeah. So I believe that everyone would like to know more about this industry 4.0. Yeah, it's about the smart automation system. Yeah, it is not like a previous automation system, but we try to integrate this what we call it smart system, artificial intelligence. We try to integrate the big data and the connectivity. So that's been encouraged by the government actually for all university to embark or to enhance, improve on this IR 4.0. Then it part of the university initiative actually to increase to improve our syllabus and curriculum, which is should include the element of IR 4.0. Yeah. So for that we try to collaborate with many companies related to IR 4.0, so we get the right perception, right idea what is IR 4.0, because not many people actually know the can explain to define the IR 4.0 actually. Yeah. So then we invite companies. For example, today we have David from Advanced Retro Resolution to share with us together about his experience with IR 4.0. Yeah, David, welcome back.
Yeah, sorry, I was disconnected. That is one of the challenges of connectivity. When we wanted to go digitalize Industry 4.0, so connectivity is
Yes.
one of the very critical.
That's okay. Yeah, that's okay. That's so
Yeah.
I'm happy to see you back on stage
Okay.
today.
Sorry for that. Really sorry for that.
Yeah,
Yeah.
yeah, yeah. Maybe yeah, you can somehow directly now share your experience with industry 4.0. Yeah, because I just give some brief idea about 4.0. Now I
Yeah.
think I pass to you so that you have a better presentation to share with our viewers throughout
Okay.
Malaysia and all over the world. Yeah, over to you, David. Yeah,
Okay, thank you, Prof. Okay,
you're
so
welcome.
very good morning to all of you. I'm going to share with you some ideas on the industry academia collaborations towards Industry 4.0. So I will spend a little bit time on the TVET skill talent development, what can be done, what we did, and also how digital twin can begin with software. So global industrial challenge. Currently, most of the manufacturers in the world, they are facing challenges. Okay, they need to reduce time to market for their products. They need to increase the quality of the products. Of course, we as consumers, this is what we want from the manufacturer. And they need to enhance the flexibility of the products. They need to increase the efficiency of the production process. So in order to answer all these challenges, the only way is to go digitalized. So digitalization is one of the very important elements in Industry 4.0. So to provide you a better insights under that four critical challenges in terms of productivity, if a companies or an organization go digitalized, for machine builder, for example, they can save up to 25% of machine commissioning time. So in terms of flexibility for chemical industries, individualized color batches of 100 liters instead of 5,000 plus liters. So the individualization is getting more simplified. So third, for time to market in aerospace industries, they spend 2.5 years instead of 6 years of development time for airplanes. In terms of water treatment, environmental efficiency will get a big improvement where the companies can supply up to 240,000 meter cube of desalinated water per day instead of 51,000 meter cube. So how digitalization happens in manufacturing operation? I believe most of us know that Industry 4.0 is all about IoT with a little bit of maybe robot integration and so forth. So I'm going to give you an overview. How can the software play a vital role in terms of the digital twin or digitalization journey? This is an overview, a simple overview of Industry 4.0, where all the working cells in a factory or in an manufacturing companies are interconnected. Data are shared across under one single platform. So what is the foundation for digitalization or IR 4.0? It is the combination of cyber physical system, which is the combination of physical production unit and a digital model. So under this special integration, all information and data can be obtained or accessed from the CPS. Basically, it can be categorized into 5 processes, which is the product design, production planning, production engineering, production execution, and services. So this might be the roadmap of digitalization for most of the manufacturing companies. Commonly, these 5 processes are disconnected in the factory. So it is necessary to integrate and digitalize the whole value chain. So each step needs to be digitalized and integrated. So the digital twin of the entire value chain is made possible starting with software. So I'm going to run through with you that 5 dedicated processes of digitalization with a Siemens NanoBox. So this is an award-winning product of Siemens, having compact design, which is maintenance-free and robust. So the requirement of this NanoBox is it has to be able to use in rough environments. It has to be high quality in industrial design. It has to be vibration and shock resistant, having wide temperature range, and it has to be electromagnetic compatible. So under product design, the first stage of digitalization, we can do design with the NXCAD software. Then we need to do testing or virtual simulation using the Sim Center or the analytics software. Bear in mind that these are the requirements during the designing stage. So in terms of testing, if anything goes wrong virtually, we can actually change the design in NXCAD and then we redo the testing and simulation. Therefore, digital twin of the product and all its variants is established. So next, we'll go to production planning, step number 2. Human ergonomics and efficiency improvement is achievable with technomatics human modeling and simulation. So with these technomatics, we can check which forces are acting on the worker's mind where the most work-related injuries will occur. So this is one of the simulation that we can do against the worker safety. Meanwhile, we can also simulate the robot motion and the work efficiency with Technomatics Robot Expert. So not only human and robot, we can also simulate the production and plant with Technomatics Plant Simulation. So with this simulation, as a factory owner, I can optimize material flows, energy consumption, and operating efficiencies. So if anything goes wrong in the process, I can actually redesign the flow, redesign the station to ensure that I can get the optimum working efficiency. So therefore, digital twin of the production process is established. Now we will go to the third process, which is the production engineering. In this particular process, integrated engineering framework for controller, HMI, and drives is achievable by using the totally integrated automation, which we call as TIA portal. This is we are extending the mechanical aspect of digital twin to cover also automation and electrical domains. Previously, we have more scope covering the designing stage. Now we are moving into the automation and also electrical processes. So with one click, we can generate the automation code and download it to the TIA portal. We can extend the digital twin to cover the plant and process. So rather than trying the new code for the first time in the real plant, which usually costs us a lot of resources and also a lot of cost, we can validate the engineering by connecting the real controllers back to the simulation interface of the value chain called virtual commissioning. So the digital twin of the production resources is established. If you notice, the plant is referenced when designing the process. The product configuration drive plant design. In short, for us to run a production of the Siemens Nanobox, I actually design the workflow, I actually design the work processes according to the Siemens Nanobox. Everything will be product-centric. So we're able to publish the optimized digital twin to all the stakeholders with a collaboration platform called Teamcenter. So Teamcenter is connecting all the data and information in one single platform, so it could be accessible from single point to synchronize data real time for all processes from all locations, and also to avoid data error and duplication. So this is something very, very important. So in the fourth stage, production execution, this is where we combine the manufacturing execution system, MES, together with the TIA in order to individualize the products coordination. So if you notice, there's a lot of black bars under this schedule or this Gantt chart. Okay, the black bars representing lost time, costly changeover, and lost opportunity. Our target as a planner, okay, is to reduce those black bars. So therefore, we can use the advanced planning and scheduling software to optimize resource allocation and secure margins. So once I have successfully reduced or minimized the black bars, this is the actual plan that I can push out to the production floor. So enterprise digitalization is possible as well by integrating MES and TIA. So with this, we'll generate the digital set of manufacturing instruction, which is the enterprise BOP, which is Bill of Process in Teamcenter. And the Bill of Process publishment is possible as well to Semantic IT. So in the same stage of production execution, electronic work instruction delivered to the right operator via workstation or AR. So when they scan the codes, they can actually see what is the instruction need to be executed by specific operators to avoid confusion and also duplication. So under production execution stage, defects are logged into the digital twin where they can be viewed and resolved by the engineering team in close collaboration with operations. But the life cycle doesn't stop here. In the optimum or final stage, under services, machine or product data generation and analysis is possible by using cloud in lifecycle management. For a machine builder, the generated machine data will be analyzed for predictive maintenance in order to improve the performance efficiency. For product manufacturer, in this case, the Siemens Nanobox, we can trace the performance tracking of the product on the entire product life cycle. If anything goes wrong in the product or the process, I can go back, I can change the parameter, and the whole data will be synchronized on the cloud. So by running through these 5 typical processes, we can reduce the time to market for the product, we're able to increase the quality of the product, we enhance the flexibility, as well as increasing the efficiency of the workflow. So will people be replaced in digitalization? I think this is one of the key questions. A lot of people will worry that they will lose job. Okay, when things go with robot, goes with IoT, human job will get replaced. The answer is no. The people is key to digitalization. we still remain essentials as creative planners, controllers, and decision makers. So these are the typical process when we interact with the cyber physical system. First stage, humans, designers, planners, testers, they have to conceptualize and design the product, which is the digital twin. Then we will determine the production rules and parameters. Next, on the third step, the CPS will simulate and compare the production options, and they will propose the compliant optimal production path, and then it will goes back to human to make decision which parameter is the best to run the production, which design is the best, which test result is the most reliable one. So at the end of the day, human will still be the is still playing a very crucial role in digitalization. So what is the key to digitalization? In fact, there are three special factors which can cause the digitalization, the efficiency of digitalization. Firstly, the government and agency, okay, they are the one who put up the national policy, they are the one who can come up with the financial aid for Industry 4.0 adoptions. Secondly, technology from the industry, of course. And third, we need skilled talents from academic. So what is next? What is the role and benefits of each other? So for industry, their role usually, typically will have to deliver the technology. They need to transfer the technology to academic. For academic, their role is developing the student skill competencies with accordance to demanding technology in market, so that the skilled resources or the skilled talent can channel back to the industry. Or therefore close industry academic engagement, for example, latest technology sharing, staff and student exposure training, skill competency validation, student employment, and so forth. This kind of activities has to be frequent and close enough between industry and academic. And today's webinar is a very good example of this collaboration. So government and agency, they also have a role to play. Okay, they have to create awareness and highlight importance of Industry 4.0 adoption, which I believe they are doing so. That's why we have Industry Forward being introduced and rolled out by the Prime Minister in last year. So they can also provide financial aids to industry and academic on Industry 4.0 adoption in terms of grant, tax rebate, incentive, to stay competitive regionally and globally. So there will be more industry willing to invest by having all these subsidies from the government. So also I would like to share with you some of our references on the skilled talent development. So we actually provide design and manufacturing solution to support Johor manufacturing. This is a ministry collaboration. We are working with MIDA, Siemens, Hitachi Sunway, CAD Doctor from the industry, working with MIDA, supplying the software, this digitalized CAD/CAM software to the Johor TVET institutions. So 5 ministries are benefited by this special engagement, which is the Ministry of Youth and Sports, Ministry of Human Resources, MARA, MOHE, and Johor Skills. So they get the software, they get the latest software from us, and they have the CNC machines, they're able to train the students, and they're able to generate the skill talent for the Johor manufacturing industry. So we also set up a digital manufacturing center in GMI. So it is powered with Siemens PLM digital solution, NXCAD, NXCAM, Sim Center, and Modex 3D plastic simulation software. In a way, GMI is currently equipped with the first and second processors of the 5 digital roadmaps. And in GMI Digital Manufacturing Center, in the same center, we run short course or short training for the final year students with the NX CAD/CAM and CAE. And we also organize a skill talent interview. We invite the companies from the industry, which is from aerospace, automotive, mold and die industries. Right after the training, we get them to interview the students. So we are glad to conclude that almost 40% of the GMI students were employed within 2 weeks after the interview session. So this is one of the engagement we are trying to pull out the companies and the training institutions. So similar training and interview program we are rolling out with Johor Skills or Puspa 3. So with the collaboration with MIDA, Johor Skills has I think 11 licenses of NS CAD/CAM and CAE. So we are using the software to train Johor Skills final year students, and we invited the companies from Johor manufacturing line. Okay, they are from most of them are from O&I companies. 30% of the students were employed in 2 weeks' time. So right before MCO, we managed to run a physical seminar in Johor Skills as well. So we are trying to introduce the facilities in Johor Skills to the manufacturing industry in Johor, and we also demonstrate the Industry 4.0 process in reverse engineering to the public. So we also involved in Asian Skill Competition KL 2016. So we are working closely with Yalong. We sponsored the training course and equipment for Asian Skill Competition KL 2016. So Yalong equipment was selected in three categories of competition, which is the smart building, IoT technology, CNC maintenance, and industrial automation. So Malaysia was the overall champion of ASC KL 2016 with total of 22 golds, 4 silvers and 5 bronzes. Okay, finally, we also set up a smart lab in Hanoi University of Mining and Geology with Siemens and Hitachi Systems Vietnam. This is the first ever university training lab in Asia, equipped with Siemens PLM, MES and TIA. So that wrap up the some of the references that we have so far. So the industrial revolution wave is coming. It hits every one of us. It can be academic, it can be companies, it can be employee. So with the right strategy and partner, the wave can actually help us grow faster and further. That wrap up my presentation. Okay, I would like to pass it back to Prof. Thank you.
Thank you, David, for your sharing.
Yes, thank you, Prof.
Very, very interesting sharing about the Industry 4.0. Maybe may I ask to clarify some of the technology? David, it's okay, yeah?
Yes.
Yeah, first of all, about this CAD cam, yeah. So I still remember, we was talking about this CAD cam since early 80s, right? So I remember that when I did my first degree, I was introduced with this so-called CAD cam. So now we already in 2020. So what is the major difference, so-called CAD cam currently compared to the early 80s CAD cam?
Okay, I think in terms of technologies, in terms of the functionalities, the features, nothing changed much. What the things that change is the capability of the machines. Okay, I think during 80s you might not have that much of axis in the machine. Now we have 9-axis turn mill, we have 20-axis milling machines. So machines are getting more complex, and the CAD cam is actually the supplement. Not to say supplement, it's actually the tools to generate the machine codes. So, but something to add up, CAD cam is no longer just a CAD cam. Maybe during 80s, CAD cam is standalone. So I have a dedicated CAD software. I have a dedicated CAM software. That's why the departments like designer will be in one room, programmer will be in one room. So physically, it is that way during the 80s or even 90s. But currently, there's a lot of data that we can share across CAD CAM simulation and also in the planning floor. So that's why just now during my presentation, we have a software called Team Center. So there are data that has to be shared across not only machining data or the machining NC codes or NC programs, but also the design data. So just imagine that when I'm a manufacturing floor, I have 50 over machines. I'm running the CAM program. Suddenly the customer was telling me that there's a change of design, but my design, my CAD CAM floor already running the production. How am I pass down this message to the machining floor in time? So it can use the software to control. I can block the drawings. I can actually notify the people by using emails. So we have elevated the communication protocol up to that that extent or that level. So there's a lot of communication can do digitally. I can get the approval of my drawing digitally in email or in my drawing. I can actually change my program and get the consent rather than printing it out and get my superior to sign. I can get digital sign because most of the people, especially now during the pandemic, a lot of
Yeah.
people are not physically in the factory or in the office. Things has to go digitally. So I believe these are some of the transformation has happened in CAD/CAM.
Okay. Yeah. Very interesting. So, meaning to say that the capacity of the CAD cam at the early 80s has been improved a lot, yeah, compared to
Yes,
current CAD cam, yeah.
yes, that's right.
Yeah. And one of the element that interests me is the CAE, computer aided engineering, yeah,
Yep.
because some of uh, organization or some of industry, they do this design process, yeah, design process,
Yeah.
yeah. So from your experience, yeah,
Mhm.
how complex the design stage computer aided engineering and can be integrated with this CAD CAM.
Okay,
Yeah.
very good questions. So most of the I think some of our clients in my ex customers
Yeah.
who is doing R&D. Okay,
Yeah.
they what they prefer to have a dedicated software which can dedicate for CAD CAM CAE under single platform.
Yep.
Okay, in a way, I'm using a brand A, just for example, Siemens. Okay, they have CAN CAE all in one. So if any changes happen, okay, I'm a designer. I wanted to design, for example, an aircon.
Yep.
So I need to design in 3D how the aircon looks like, how economic, how fancy, how stylish it is. I need to do the design, but at the same time, I also have certain criteria or requirement to meet in terms of the electrical efficiencies. So I need to do a lot of
Yeah.
connectivity things in my aircon. If I use this motor, what will be the performance,
Yep.
the noise level, and so forth. So all these things can actually adapt into the CAD CAM or the CAD and CAE software. So rather than I do a design and I do a build a prototype, I switch on the aircon and see how it works. I can actually do all this testing in the CAE software. In fact, this is what my industrial customers,
I
previous industrial
see.
customer doing. So there will be a lot of through and flow, meaning that there will be a lot of testing. When I do this design, I will
Yeah.
go to
Yeah.
the CAE software, I'll do testing. Maybe the thickness is not correct,
Not.
the test result is not satisfying. I need to do changes here and there. So the good thing of digital is you can do multiple changes, and
Yeah.
it cost zero of
Yeah.
resources, cost
Yeah.
zero of your cost. You just have to buy the software. So the most of the time, the industry will prefer CAD, CAE, and CAM integrated under one single platform because if there's
Yeah.
any changes, the things will click just one click, everything will synchronize immediately. So traditionally, if they have different CAD, CAM, CAE software, what they have to do is the CAD, after doing design, they will go to another CAE software. They do the testing. They need to do some modification. If anything goes wrong, they will go back to the CAD. They need to change the CAD format. They need to change the design, and then they need to export again. So that is the
Okay.
difference. Yeah, that's
Mm-hmm. So meaning to say that there's some iteration process going on, yeah, in order to make the product become refined from the computer aided engineering to the CAD CAM, right?
that's correct.
Yeah. Yeah. So that actually trigger my interest, David, because
Yep.
in Malaysia we have a group of, we call it research university. Yeah.
Yeah.
So this research university, they are more focusing on design, which is computer aided engineering design actually. Yeah.
Yep.
And then we have a group of TVET, yeah, which is more on
Mm,
skills, with vocational. Yeah. Even
mm,
2 weeks ago, I was approached by officer from the TVET, yeah, because they also would like to collaborate with industry, yeah. So and
mm.
especially on this IR 4.0. So I'm now trying to think what is the best avenue, yeah, to collaborate, yeah, between the research university and this TVET institution, yeah,
Mm.
and the industry. So yeah, if you do you have any suggestion or any kind of proposal how we can link this together? Otherwise, the research university just doing CAE, so they're disconnected with this TVET, eh? But somehow the engineering is supply chain, right? It's supply
Yeah, yeah,
chain,
yeah.
yeah.
That's correct.
So the thing is, some of the chain is some we need to link it. So do you have any opinion or suggestion on that? Yeah, so that we can
Yeah.
work on.
Yeah, that I think that was something that I previously aggressively to form up those so-called industrial academia consortium. Okay,
Mm.
where yeah, certain TVET institutions or R&D universities, they are very well versed in certain research, but
Yeah.
they might not be that well connected to the industry. So maybe the industry don't even know that they have that kind of high-end CAE software in a way. So
Mm.
that's why just now I was introducing like Johor Skills. We actually sell them the solution or sell them the CAD/CAM software, but we're also helping them to promote what they have
Mm.
invested previously. What is the skill competency level of the students? So rather than setting up a lab or setting up a technology centers, I think moreover we also need the what we call, they might need to be more partners like us who actually go to assess the companies in the industry as well as the institutions. We need to link all these people together. Okay, it
Mm.
can be a train the trainer program, it can be technology sharing, it can be a skill competency validations. So there must be someone who fund this or to drive this, I believe, because
Mm.
these are something that industry not willing to drive this because to them they are businessmen, right?
Yeah.
There's
Yeah.
nothing
Yeah.
in return. So to the academic, this is not under the syllabus, so why should I
Yeah.
go front? So in a way, to be frank, this has happened so many years back, and
Yes. Yes.
that's why all this while there must be some NGOs or bodies or companies or particular entities who actually drive this. And this is something that I'm aggressively doing now. I'm trying to link up the specific industry and also the TVET institutions, and I will try
Mm.
to study what is the potential things that we can invest. I mean, not to say invest, we can integrate and exchange the value, the intersection values in between.
Yep.
So I think the drivers is very important. The
Sure.
technology is there
Yeah.
in the industry, the talent is there in the university, but how to get this thing connected together
Yes.
frequently? Yes,
That's right.
that's the yeah.
Yeah. Thank you, David. I think we have one question from the viewer. Yeah. Uh,
Mm,
Hakimin Abdullah.
yeah.
I think he has two questions. First questions, do you think the current curriculum structure of higher education institutions in Malaysia is in line with IR 4.0? That is the first question, yeah, David. So second
Mm-hmm.
question that I read an article about the Industrial Revolution 5.0, where it refers to man and machine work together to achieve a particular objective. What's your opinion about the IR 4 point? Sorry, IR 5.0.
5 point.
So yeah,
Okay. So the first question is the current curriculum structure in line with IR 4.0? Frankly, not really. Not really,
mm,
because I think it is a massive work for the for the ministries or for MQA or from JPK to revise or to revamp the structures or the curriculum of the TVET
mm,
institutes. So I believe this is a massive work. And what we usually do is we will have additional or complementary course syllabus to get things in line with IR 4.0. So
mm,
the answer is, so far I don't think so. The curriculum is in line with it, but the ministries or the government is actually quite concerned about this. That's why they have a lot of initiative. I believe MITI was one of the agency. They have the industry at the university program. They wanted the university to invest in IR 4.0 related equipments. They wanted to set up the competence center. So regardless of the curriculum structure, they're still wanting the industry and academic to look into industry 4.0 adoption. So I think this is
mm,
something very good. And in terms of curriculum, I think this might be the work from the ministries maybe to
The policy,
to yes, yes, the policy, yes, the
policy
policy.
makers. Yeah, yeah,
Yes, and the second questions was about the IR 5.0.
yep.
Okay, and man and machine work together to achieve a particular objective. So maybe
Right.
I can give some ideas in terms of IR 4.0. Frankly speaking, even the industry is not ready with IR 4.0 yet. That's why the government, especially MITI or MIDA, they keep advertising, they keep giving grants, they keep giving
Ah,
subsidies,
okay.
because the industry, for big companies, of course, they might be more willing to invest in automation, in
Yep.
ICT or
Mm.
IoT. But for SMEs, to be frank, 80% of the local industries in Malaysia are SMEs. So those are the group of companies who might potentially employ students or engineering students from the TVET institutions. We need to take care of this 80% of SMEs. So they are not so willing to move into IR 4.0. So that was like
Mm.
6 months ago. But due to COVID, a lot of companies they need to go digitalized. A lot of
Yep.
things change. That's why we are
Mm.
here today digitally. Okay, so it might take some time for the local industry to go into IR 4.0, but I can see the trend there. So to Malaysia, frankly speaking, just my personal opinion, I don't think so. They are ready for IR 5.0 yet. So, but to get ready for IR 4.0 and to connect industry and academic together, I think this is one of the major works that we
Yeah.
need to focus
We need to focus.
at least until next year. We need to make sure that the IoT is stable enough, the integration of industry and academic is strong enough. I think that's the major things that we need to focus
Yes,
at the
yes.
moment. Yes,
Yeah, David. Yeah, this is the important thing that we need to narrow the gap or the mismatch between the agencies, so then we can make it as holistic program that can drive the whole this IR 4.0, right? Yeah.
yes, that's correct.
Yeah. So
That's
so that's
correct.
it. Yeah. So I believe that this is important about the quadruple helix, where the government agency, the university, the community, and the industry, they work together, and we put this IR 4.0 as a platform, so we can collaborate together and we can form something, a policy that can drive this IR 4.0. You can, I think, more faster. If we just wait and see, then I don't think
Yeah.
we gonna up to date
That's right,
with
and
with this.
something
Yeah,
to add on. In fact, IR 4.0 has been a hot terms since I think since last 2 years until now. People know that it is IoT, it is the fourth industrial revolution. That's why during my previous presentation slide, I go in depth a little bit on how actually small manufacturing companies who is doing a CAD/CAM businesses can
yeah,
go digitalized, because sometimes they might think that, oh, I do not need robots, I do not need the IoT. In fact, there's a
mm,
lot of things in the designing floor, in the production floor, in the planning floor, in the purchasing floor. There's a lot
can
of
be.
things that they can go digitalized. So
Yeah,
these are
yeah,
something related to IR 4.0 as well.
yep, that's
Yes.
right. Yeah.
Yeah.
David, we have one more question from our
Yeah.
viewer, from
Yeah.
Muhammad Nazim Abdul Hamid.
Yeah.
Is it software from Siemens can use for additive manufacturing, slicing software?
Okay, the answer is yes. In fact, Siemens Digital Enterprise is working very closely with DMG. So one of the reputable machine builders in the world. Okay,
Yep.
so they can actually do. I mean, Siemens CAD/CAM can actually both do both sub subtractive manufacturing as well as additive manufacturing. So AM, I think, is something not really new, but it's something very new in Malaysia. But in other countries, I think it is quite common in the oil and gas industry, especially for MRO, machine repair and overhaul, where you can actually scan for example, there are certain big parts in the oil and gas. You have a very big components wear out. You need to remachine it. Okay, rather than buy the whole things from the manufacturers, you just have to machine out the components. So they will do using the scanner. They will scan it and then they will send to the machine. They will do the subtractive manufacturing and additive manufacturing at the same time. So AM is actually meant for cutting, which cannot be done
Mm.
in, and they do it quite well with DMG. So it is a collaboration. You see, that CAD-CAM always has to work very closely with the machine builders, and in fact, Siemens is doing quite well on this.
Yeah.
Yeah.
Yeah, David. Move on to this the progression or development of this IR 4.0 in Malaysia, and many of our, I mean, local people also concerned about this. What we call it, the percentage of local product in the development expansion of the IR 4.0, because in Malaysia we always keeping, I mean, listen to that, oh, the product, the machine come from abroad, but how actually that we would like to increase the local content of this IR 4.0 for the Malaysian. So it's not going to be that Malaysia just an end user and using the
Mhm.
equipment, but we also need to get involved, and then we need to put our thinking on our effort that to increase the local content of the IR 4.0 facilities as well. So what your comment on that? Yeah, David. Yeah.
I think so far the localization of the digitalization contents are still manageable by local manufacturers in Malaysia. Why am I saying so? Because when we goes for even IR 3.0, when we talk about automations, okay,
Yeah.
when we talk about robots, pick and place, all those kind of things, the customer or the manufacturer is the one who have to actually design the automation
The
process.
automation process.
Yeah,
Yeah.
so whatever we import or we buy from overseas or abroad is actually the technology. Okay, robot. Okay, in fact, we don't have to build our own robots, but
Okay.
we should be the one who design the process. We must know how many stations of robot need to be there for my product brand A. If I goes to model A, if I goes to model B, maybe 50% of the robot has to be idle, another 50% has to be full force. If I go for model C, maybe 70% of the machine go robot go idle, 30% will be full force, and so forth. So all this production process will be depending on the so-called the local companies.
The
So the
companies. Yeah.
localization, in fact, I can't see much problem, because now the major barrier is might not be localization, but how to, I mean, the willingness of going into
Yeah.
digitalization. I think
Yeah. The
because a
willingness.
lot of people will think this will cost money, and
Yeah.
the
Yeah.
things was like, okay, there are also some of my industrial customer previously sharing that, okay, they might have that investment with the support of government from the grant. They wanted to invest, but what they worry is there anyone who can comes in and support the technology?
Yeah.
Because now I couldn't find good, I mean, not to say good, skilled, competent students or employee who can run the system for me. So you see, the thing is that industry wanted to go in.
Yeah.
The barrier not because of the cost
Yeah.
only, but also the skill talent.
The skill. Yeah.
So yes, 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 yes,
And
yes.
the
So this.
yeah, and the willingness as well.
Yes. So the willingness is some. I think most of the time is money. Okay.
Money.
So as
I
long
see.
as
Financial lah,
the
financial. Yeah.
government is playing their role to advertise, to promote the supports from them, I think the most of the companies will still willing to consider. Okay. And secondly, to make them feel more confident and comfortable is, okay, don't worry, when you really go adopting Industry 4.0, we will have a group of students from the Malaysian local engineering institutions who can come in and help you to run the digitalization businesses.
Yeah.
So
Yes. Yes.
so
Yes.
it has to be two ends, you see. That's why you see the key has to play each roles diligently and evenly.
Yeah.
Yep.
Yeah. Yeah. Because I I I always make some conclusion that in order to develop something new or something advanced, we need to have three things: the technical, the financial, and the commercial. The commercial,
Yep.
three main things. Yeah,
Yes,
but
that's
I
correct.
don't think I don't think we don't have much problem on the technical. I think we have the capability locally that have the technology, can develop the technology, but the next two things, the financial and the commercial, that's maybe the yeah. the barrier that actually we need to think of to, I mean, to support or to what do you call it, to make some easy leeway that we get some financial support and also some commercial point of view, things like that. Yeah, that's
That's something very just to share. I saw something very promising in the last
mm,
6 to 9 months where principals like Siemens, they are very aggressively, especially of course they do commercial business, but at the same
mm,
time they are very willing to support the academic. That's why sometimes they will provide good support, good solutions to academic together with us. And I also see
mm.
likewise the response from the academic are also very encouraging. That's why we
Yep.
have a lot of good centers set up in GMI, in
Yeah.
Johor Skills, and industry also giving a very good response in terms of when we have seminars, when we have students interview or skill competency validations, they are willing to step out, they are willing to explore. So I think the chemical reaction is actually there.
Yeah.
So somehow we need to refine the formula so that the impact will exaggerate
Yeah. Good to hear, man.
to the
Yeah. Mm.
expectation that we look forward. Yes.
Okay. Thank you, David. I think we have one more
Yep.
question from Xuan Han. Is 5G
Mm.
is important to Industrial 4.0, especially in remote robotics technology, AI, as it requires instant response to prevent accident happening such as driverless taxi, remote surgery, flying drone, etc., etc. That's the
Yes.
question, Xuan, yeah, from Xuan Han. Yeah.
Okay, I think the the answer is definitely yes. In fact, I have the same questions 2 years ago when we are running IR
Okay.
4.0 seminar in UTHM. So
Mm.
there's also a question on, I think that point of time is still 4G, not 5G yet.
Yeah.
So they're
Mm.
asking is 4G is important in order to have things digitalized and automated. So definitely yes, but I would like to conclude it in a different manner. So for manufacturing industry, I think at the current connectivity and the internet environment is still
Mm.
okay to proceed with the digitalization. But when things go to life saving, like the surgeries, uh, which really requires strong connectivity, I believe 5G is something mandatory. But
Mm.
for
Okay.
production
Mm.
process, in terms of 4G, if there's any lag, you might have certain maybe a few seconds or a few milliseconds of delay, but that doesn't affect much in the production process. So the
Mm.
production will still goes on. But when things go to surgery, I think every seconds count. So this might be something very crucial to to take
Yes.
note.
Yes.
Yes,
Yes.
yes, yes.
Yes.
But I
Correct.
think as a whole, 5G might definitely be the mandatory of, I mean, to have a very strong environment, right? You see, sometimes when
Yes.
we have
Yes.
webinar, we might have connectivity problem as well.
Yes.
So 5G is a must.
So again, from my observation, so this IR 4.0 require three major things. One is the AI itself, one is the
Mm,
data, the big data, and the last
mm.
one is connectivity. Yeah.
Yes,
So if
correct.
we keep on talking about big data, then we keep on talking about this what do you call it? The AI, artificial intelligence, things like that. But if the connectivity is not so good, not up to the level that we can manage the
Yes,
data and then to compute the algorithm of the AI. So actually, we're missing something that very important, which is the connectivity. And I think the
correct.
infrastructure to develop the integrity, the connectivity is very important. What do you think,
That's
David?
correct.
Yeah.
Yeah, 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 that's correct. And you see, even I think some of the companies, when we talk about IoT for production companies or in the manufacturing floors, by using tablets, by using handphones, they can actually see what is the condition of their CNC machines, how
Mm.
many machines has broken down, what is the production output, how many parts has been produced. So, frankly speaking, technology is very common now. Okay, every one
Mm.
of us have the smartphone, and these are the things are being utilized. I think not only manufacturing business, in
Yep.
fact, I think
Mm.
bookstore, food
Yeah.
ordering, so cinemas. So in fact, everything goes online, goes digital. And manufacturing, I think 5 years back we cannot think of internet and manufacturing in
Yeah.
in one table, okay, because
Mm,
this is
mm,
disconnected, okay, everything is disconnected, okay, manufacturing is manufacturing, ICT is ICT, but you see, I believe later on the
mm.
cost structure will somehow be, there will be some ICT elements in the engineering cost outline. Likewise, there will be some engineering cost content integrated in ICT, because we cannot get away from this. ICT engineers must also have some manufacturing knowledge, and likewise for manufacturing engineering graduates, they must also have some ICT knowledge. So,
Yes,
and this
yes,
is the
exactly.
expectation from the companies actually, because they have all these technologies. They expect the students to have certain knowledge in different fields, and that's
Mm-mm.
where academics will need to. There's some work for the
Yeah,
academic to do. Yeah,
yeah, to improve our syllabus curriculum. Yeah,
yeah, with the help of the
yeah.
governments.
We
Yes,
had the
yes.
government. Yes, yeah. So
Right.
I have one more question. Is through your experience,
Yeah.
I think some of the element that Malaysia require is a transfer of technology as well
Mm.
from the developed country. So, do you have any experience on how this transfer technology program being done or can be implemented uh, uh, for the IR 4.0?
Okay, so far my experience, rather than the country or the companies who is doing the technology transfer, what we are
Mm,
having now mostly, we have a very great support from Siemens particularly. So they, just now, if you, I mean, during my last slide on the skill development
yeah.
references, they actually set
Mm,
up the first ever Siemens Smart Lab in Asian, who has the PLM, product lifecycle management, the MES,
mm,
manufacturing execution system, and the
yep.
TIA portal. So Siemens was supporting the industry worldwide. So in fact, there's no borders in terms of technologies.
Yep.
The support team don't have to be physically here in Malaysia to transfer the
Yep.
technology, because they
Mm,
have a very strong pool of technical teams. So whatever technology which was successfully implemented in other countries, they will try to localize it and try to replicate it and refer it to the local industries, local institutions. We are glad that Siemens is part of the big players who is supporting us on driving these directions.
yep. Mm. Thank you. Yep.
Yep.
Thank you for the answer, that
All right.
David. Uh,
Okay.
do we have more questions? Yeah. Yeah. We have one more question. David from Kashif Imran.
Mm.
Uh,
Mhm.
he is asking, can we include 3D printers as part of Industrial 4.0?
Okay. The answer is definitely yes, because okay, I mean, just to share with you also the one of the industrial experience on 3D printers. We have agencies in Malaysia. I cannot declare the name. So what they do is they are handling the insurance for the handicapped people. They have injury because of work, and they need to have the. This is more on the prosthetic and orthotic. Okay, maybe they lost their leg, they need to have the so-called the framework of the leg they need to build. So what they do is they actually mold up the knee structure, and they will try to rebuild the
Oh,
mold of the leg and put it
mm,
back on the persons. So this has been done manually with hands. So it takes time for them, maybe 2 to 4 weeks time, just to mold up the things, and then the
yeah.
patient has to wait, like for example, 6 weeks to get things done and fix back onto his knee. So with the Industry 4.0 adoption, what they do is they actually using the 3D scanner, they scan the
Mm,
knees of the patient. Okay, the 3D scanner is actually carried a scanning process is actually handled by not by engineers, it's actually by the doctor. So the doctor is actually carrying the scanner,
yeah.
scan the legs of the
Yeah.
patient.
Mm,
They get the 3D
mm,
models. They are using the Siemens Solid Edge software. They are
mm,
trying to compute the knee structure, the gap of the structures, and they will try to come up with the brackets, and they send it to the 3D printers and build the frame. And when it fixed back to the leg, okay, perfect. So the process was like cutting down at least 60 to 70%. So the patient will get the legs maybe in sooner time, and the suitability and the comfortability of the bracket is much better as compared to before. In fact, you see, IR 4.0 can goes to everywhere, not only manufacturing but also
yeah.
P&O industries, medical industry. So that's one of the very good examples for 3D printers.
Yep.
Yep.
Mm. Thank you, David. I think
Thank you,
we
Prof.
Yeah, we're the end of the 1 hour session.
Okay.
Thank you so much, Mr. David, for accepting our invitation. And it's our privilege to have you
Thank you,
today.
Prof.
And then,
Thanks to
yeah,
you, TM.
you're
Yes.
welcome, actually. So, yeah, we are trying to our best to share all the question just now with our viewers. So if
Okay.
anyone has any question, maybe can ask me, or maybe I can pass to David next time, because we are really looking forward um, to work together with you and with Simon as well. Yeah.
Yep.
So
Yep. Yep. Sure.
yeah, you can become a contact person. Then we can
Yes.
think of something that to drive this thing
Yes.
fast. Yeah.
Yes. 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 Of
Yeah.
course. Of
Yeah.
course. We look forward. We look forward.
All
Yeah.
right. Okay,
Okay.
so for the viewers, we have to say sorry for the connectivity problem just now. Yeah, this is IR 4.0.
4G, right?
So sorry for that, but we managed to come back. So I hope you all enjoy with our today webinar. Thank you. And then please stay tuned with our next webinar, Leaders of Enterprise. Okay, David, thank you so much to be with you here. And do you want to say something before we end our sessions?
Okay, thank you, Prof. So, to the audiences, they can be a casual audience, they can be from industry, they can be from education sectors. So, IR 4.0 is something very big, but please believe that there are someone like us who is helping the industry and the academic to bond and connect together and make things happen. Because industry alone, academic alone, things might not happen. Okay, we need supports, we need the connectivity and collaboration engagement from every parties. So these are something that, okay, uh willing to expose, and please keep in touch if any things that we can help from UTM or from myself. Yeah.
Yep. Thank you, David, for your
Okay,
insightful
thank
words.
you, Prof.
So,
Thank you very much.
from behalf of UTM, we want to say you thank you so much and hope to see you
Okay,
again. Bye
you're
bye.
welcome. Okay, thank you, Prof. Thank you all. Bye bye.